Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating GitHub project, a fork of the Amsterdam compiler kit, ACK, tailored for the legendary Cray XMP supercomputer and its COS operating system. It's a real blast from the past.
A Cray XMP? Wow, that's seriously old school. So what makes this ACK fork special? Is it just a simple port?
Oh, it's much more than a simple port. This isn't your average compiler adaptation. This fork specifically disables support for all other platforms, focusing solely on the Cray XMP and COS. The build process itself is quite unique, requiring a specific set of tools, including Bison, Flex, GCC, Gmake, and Lua. Think of it as a highly specialized toolchain.
Right, I see. So you need to install all those tools first. And what about the operating systems? Does it work on Windows?
No, not directly. It's designed for macOS and Linux. The instructions are pretty clear on how to install the prerequisites using apt on Debian-based systems or Homebrew on macOS. They even highlight the need for GNU GCC and Gmake, specifically stating that Xcode's version won't work. Critical detail.
And what about the Cray XMP specific tools? Where do those come from?
That's where it gets even more interesting. The project relies on another GitHub repository, COS Tools, which provides a cross-assembler, cross-linker, and cross-library manager specifically for the Cray XMP. It's a complete ecosystem for building software for this vintage machine.
So after all that setup, you can actually compile code for the Cray XMP. What languages are supported?
Absolutely. Once you've built ACK, you get cross-compilers for BASIC, C, and Pascal. You compile your code, and it generates an absolute binary .abs file ready to run on the Cray XMP. Amazing!
But how do you actually run this .abs file on a Cray XMP? I mean, these things aren't exactly lying around in everyone's basement, are they?
That's a great point. That's where Andres Tantos's Cray supercomputer simulator, CraySim, comes in. It simulates the Cray XMP with COS 1.17. However, there's a catch. The recovered COS 1.17 doesn't include any language translators, which is where this ACK fork becomes invaluable.
So ACK acts as a bridge, filling a gap in the historical record? That's pretty significant.
Precisely. But even with the simulator, getting the compiled code onto the simulated Cray XMP is a challenge. The project suggests using DT Cyber, a CDC Cyber Series simulator running NOS 2.8.7 and leveraging CrayStation software to transfer files between the two simulated systems. It's a multi-step process involving FTP, Telnet, and even CCL procedures.
Wow, that's a complex workflow. It sounds like a significant undertaking just to run a simple "Hello World" program. I'm curious, is there any documentation on how to actually do this?
Yes, the README provides a detailed walkthrough, including a complete example of compiling a Fibonacci sequence program in C, uploading it via FTP to the NOS 2.8.7 system, using a CCL procedure to transfer it to the Cray XMP simulator, and finally, retrieving the results. It's a fascinating case study in how to work with legacy systems and simulators.
This is incredible. It's like a historical puzzle, bringing together modern tools with vintage hardware and software. It's a testament to the power of open source and the dedication of the developers involved. I'm definitely going to check this out.
I highly recommend it. It's a fantastic example of how modern technology can help us preserve and interact with the computing history. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Cray XMP and ACK. Have a great day.
Bye-bye.